Let's look at another example of using the sampling distribution of a proportion. So on the 2018 election, voters in Oregon, among other things, voted on Measure 105, which was a measure to repeal Oregon's sanctuary law. And you can see from the results here, the measure failed by quite a wide margin. So P equals, if we define it as the proportion of voters in favor, it's 0.365, which I got from this number. Now, of course, before the election, though, we don't know what that is. So if we took a random sample of 175 people, we want to know what's the probability that over 50% of them would be in favor. Like, you don't know what this is, but you want to see, is this measure going to pass? So we define P hat as the proportion of people in your sample who plan to vote yes on Measure 105. So P hat has this mean of P, standard deviation of P hat given by this formula again. So the mean, 0.365, excuse me, typed the wrong number there. The mean is 0.365. The standard deviation is this formula, 0.365, 1 minus that divided by 175 people. So what is the probability over 50% would be in favor? You put that into GeoGebra with this mean and this standard deviation. So 0.365 and 0.0364. I didn't mean to make those numbers so close together, but it worked out. So just setting up your normal model, the mean of 0.365, you can see that it's very unlikely to get a sample with more than 50% in favor because that's a number of standard deviations above the mean. But if you set this up with the upper tail, you can do 0.5, and it calculates the probability as 0.0001. So you might type something like GeoGebra says the probability of this happening is about 0.0001, which is very unlikely. So if you're doing some polling before the election and something is not going to pass, like it's not even going to be close, there's not much chance that your sample statistic is going to be close to that. If this had been a much closer matchup, then this probability would be much higher, but it wasn't.